I think everyone can able to see my screen, right?
Yes, we can see the screen.
Okay. So let me just pull up the PDF here. So we are discussing about this final project. Hello, everyone. We are from group 7 from machine learning class. Uh, our instructor is Zipping. Our instructor is Zipping Lu. So we are gonna discuss about our final project on Kaggle competition. That is, we are taking some data sets from this Kaggle competition links, and we are gonna do some operations which we have learned on the class so far. So let me just tell you briefly what the Kaggle is. The Kaggle is a platform for data science competition, data sets, and a community of data scientists and machine learning practitioners. Kaggle competition, often referred to as Kaggle competitions or challenges, or organized events where the data scientists and machine learning enthusiasts from around the world can participate to solve specific data related problems. In a Kaggle competition, participants are provided with the dataset and a well-defined problem statement. The goal is to build and train machine learning models that can accurately predict specific outcomes or solve the given problems. Competitions submit their predictions, and the performance of their models is evaluated based on predefined metrics. Kaggle competitions are a way for participants to showcase their skills, learn from others, and sometimes with the prizes, which can include cash rewards. So this is about all the Kaggle competition. So we have taken some data set from that following link, which you are able to see here, right? So we have posted that what we are taking and everything. So let me just go through the description of the data which we have taken. This is the one. My dear Watson, detecting contradiction and entailment in multilingual text using TPUs. This is the data set we have taken. So you can find the link here. So what the data set description is about: the task at hand concern natural language inferencing, NLI, more especially text entitlement. Participant create an NLI model that can identify sentences 0 for entailment, 1 for neutral, and 2 for contradiction. Given a pair of state sentences that each contain a premise and a hypothesis, the competition intends to investigate whether machines are capable of efficiently identifying logical connections between phrases, which has important ramifications for text analysis, fact checking, and the detection of fake news. For this challenge, a data set with the text in 15 different languages is offered. The task at hand is to create models that in a variety of linguistic settings can reliably anticipate the connection labels between pairs of premises and hypotheses. In order to effectively tackle this NLP problem, participants are advised to make use of the potent hardware accelerators known as tensor processing units, a unique identifier for each data instance premise. The first text serving as a basics for comparison hypothesis, the second text being compared to the premise. This is lang underscore above, the language abbreviation, the language, and full language name and label. The label indicating the logical relationship between the premise and hypothesis are the among the column that make up the dataset. The values of 0, 1, or 2 for the label present entailment neutrally and contradiction respectively. This meaningful dataset provides a real-world scenario where NLI model must handle a variety of linguistic patterns and relationships. And the goal in this project main objective is to create reliable NLI model that can correctly anticipate the logical connections between text pairing in a variety of languages This entails integrating TensorFlow high-level API with Keras to create at least 5 machine learning algorithms or models with the necessary inclusion of neural network model. That is ANN, CNN, or RNN. The project also calls for extensive model evaluation, hyperparameter adjustment, and the dimension reduction or feature session strategies. To comprehend the label distributions and language trends, participants are encouraged to perform data analysis. The study should offer insights into model performance, possible difficulties, and any noteworthy patterns found in the dataset. The resulting model should be able to handle the subtitles of multilingual text entailment. The participants are required to provide prediction in the prescribed CSV format for a test set of 5,195 entries. The submission is assessed based on the accuracy. So here we are taking the data set. As you can see the data set, we have we have taken 3 data sets here in this assignment, and we are as like before, we are training the data here, train underscore data, importing pandas as PD, and we are reading the CS1 of the CSV file, that is train.csv file, and we are just displaying the data in train. Okay, so this is the data which we have got, like it has n number of rows. As you can see here, it has 12,000 rows, more than 12,000 rows. Okay, so it has got ID, premise, hypothesis, lang underscore above, language, and label. These are the columns and rows you can see here. And so the data set, so this is all about the data set. The data set comprises of 12,120 instances with 6 columns, including ID, premise, hypothesis, and language and label. These are the columns which they were talking about. Each entry represents a pair of text sequences denoted as the premise and hypothesis, accompanied by the language information and a label indicating the logical relationship between the two texts. The lang underscore ABV column provides a language abbreviation such as EN for English, F for French, and TH for Thai. The label column assigns numeric values, that is 0, 1, or 2, to signify entailment, contradiction, or a neutral relationship between the premise and hypothesis. For instance, the first entry in English indicates no contradiction, while the second entry in the English disputes a contradiction that is labeled to between the practice groups. Permissibility and actual work undertaken. The dataset is diverse, spanning various languages and a logical relationship, providing a rich source of natural language inferencing tasks. So here is the testing the dataset again. In the above one, we are training the data, and here we are testing it. So test data. So actually, these are the data which we are just showing it till we didn't have any test and train. So we are showing the test data now. Test.csv. It has a same as above dataset. It has got the same columns, and also it has got only 5,000 instances. So as it says, like dataset contains 5,195 datasets, which contains like the same columns in the above, and it says like FR for French, JH for Chinese, and RU for Russians. This multi-language dataset is designed for a natural language interference task, aiming to predict logical relationship between pair of text sequences in different languages. The premise and hypothesis variation across languages presents a unique challenge for NLP models to accurately determine entailment, contradiction, and neurality. So here we are seeing the info of the train data. Train underscore dot info. It shows like the column names, and as you can see, whether it is a null or not null, and the type, data type. So you can see the details of the train data clearly here, and So as you can see, the memory usage, it says like 568.3 KB, and the train data frame has so it just mentioned about everything which is over here. Okay, anyone can understand by seeing this. So and when coming to the describe, so this shows only the label and the count, like how much what is the count, mean, STD, standard minimum, 25%, 50%. So this shows the train data describe, this shows this one, and the descriptive features for the label. So we are showing only for label encoded columns in the train data. Data frame indicates that the labels are distributed across 3 classes, 0, 1, 2, 3, 0, 1 and 2. With an average label value of approximately 0.99. The standard version is 0.82, reflecting some variations in the distribution, and the minimum and maximum label values are 0 and 2 respectively. Here we are importing all the libraries, whichever is useful for us. So I'm importing, now I'm using the new one, Seaborn here, which we didn't use before. So as you can see, I have used all the import statements which we have used, which have been using from the past all assignments. So these are all we are importing it, and here we are printing the loop here. So as you can see, the values of NRPD dot unique train data. So this is the result of this one. You can see the result. The value of IDs are this one, and the values of premise are the values which are there in the premise is all of this. Okay, and so the values of hypothesis is this, and the value of a language and underscore above are this, the short forms of the languages, and the values of the language, the original values are here, and the values of the labels 0 to 1. So this shows everything, like whatever the ID means, premise, hypothesis. So it describes about all the table columns which is there in that. And coming to the train data head under in 5 means, as we all know about this, right? I mean, so it shows the top 5 rows, right? So we are showing the top 5 rows here and the train data. And coming to the data visualization, ignore about this one. This is just a warning, it's not an error. So DF is, so we are taking the train data and mapping the labels to the human readable names here. So as you can see, the entailment and neutral and contradiction, we are assigning it to 0, 1 and 2, and create a subplots, fix axis. So this is the following key code for that, and we are plotting the distribution of the labels with the actual labels in this code. So as required, we have plotted all the distribution of labels, the actual labels, and plotting the distribution of languages here. We have done so far, and rotating the x-axis table. This one represents the rotating the x-axis label for the better readability. So we are plotting the we are showing it. We are plotting the tight layout, and we are showing how it is being discussed. So as you can see here, the distribution of labels. The distribution of labels is this one, and you can see the bar graph, entailment, contradiction, and neutral. So the x-axis is its count and y-axis is its label. And coming to the distribution of languages, you have got like it starts with 0, and the maximum is 7,000. And you have a various of languages which is given here. So as you can see, the English is taking the high value in this graph. So what is this about? The provided code aims to visualize the distribution of labels and languages in a data set. The first plot illustrates this one. about this one. Illustrate the distribution of labels with the axis. X-axis represents the various columns 0, 1, 2, and y-axis indicating the count of instances for each class. The second plot visualizes the distribution of languages with each language category labeled on the x-axis and the corresponding count of instances represented on the y-axis. The counts are displayed as bars, providing an immediate visual insight into the distribution of labels and the languages in the dataset. The label distribution plot indicates the frequency of occurrences for each classes, allowing for the assessment of the dataset class balance. Similarly, the language distribution plot shows the number of instances associated with each language category. Understanding the distribution is crucial in machine learning tasks, as imbalances or biases in the dataset can impact the performance and generalization of models. These visualizations serve as a valuable exploratory tools to comprehend the data's characteristics before proceeding with the modeling or analysis. So we are doing the data pre-processing here. So we are importing the necessary libraries, whatever we need to show this result. So sklearn pre-processing, feature extraction, model selection, df underscore train equals to train underscore data. So the label to count. Can someone go on a mute? Please go on a mute. I can see the label coded to convert the categorical label code into numerical. Vicky, can you go on mute? Label encoder equals to label encoder df underscore label encoded. So this is the following code for data pre-processing. So we are displaying the result here. So the label encoder is applied to the label column in the df train data frame. The fit transform method of label encoder is used to convert the categorical labels. So these are the labels into numerical format. So these are the formats 0, 1, 2. The resulting label encoded columns is a new numerical representation of original labels, which is essential for training machine learning models, as they typically require numerical inputs. This modification allows us to use the labeled data for supervised learning tasks to facilitate the training and evaluation of the models on the data set. So as you can see here, we are showing the data present in the train. Okay, we all know that we have this data already. We have seen that, and combine premise and hypothesis columns and apply TF-ID of vectorization. So we are combining the premise and hypothesis column and applying the TF-ID of vectorization here. So you can see the output of the data which we have taken by combining the premise and hypothesis of train. Okay, we have combined both the datas. So it is used to perform term frequency. What does this mean? TF underscore TF-IDE means term frequency, inbox document frequency, vectorization on the combined text for premise and hypothesis columns. So this one, to transform the text data into numerical feature vectors, where each feature represents the importance of a term in the context of entire dataset. The max features is 5,000. Parameter specifies that the vectorizer should consider the top 5,000 most important terms, controlling the dimensionality of the resulting feature space. This numerical representation of the text data is crucial for training machine learning models, allowing them to operate on the transformed input data. Splitting the data into training and validation sets. So here we are splitting the data into the training and validation sets. So x underscore t, it represents the TF which we have just discussing about, TF underscore IDF vectorization. So this is a actual X train and TF IDF vectorization. So you can see the data, combined data, And I'm printing the XY_ train data here. As you can see, then names are label encoded. On the length it says 9696, and the data type is integer 64-bit. So coming to the models, so far we have used random forest, k-nearest neighbor, decision tree, and gradient boosting. And also we have one more model in the bottom, that is let me show you that. We have one more model, RNN, using Keras. We have already discussed about it. Okay, no problem. So we are here, right? So converting the y_val to binary format, and we are getting a predicted probabilities for each class, and so we are showing all the plot of graphs here, ROC curves for different models. As you can see here, random forest 0, class 2, and everything. It is the graph is showing all the curves which has all the models. Random forest with the class 0, 1, 2, 1, 2, and you have a different class, and the RO. So it states the graph about the graphs. It talks about the graph, and in this we are importing the NumPy, and we are training the model here, x_train dense equals to array. And as you can see, this is the model we were talking about. The other, this is the fifth model. So this is here we have discussed about 4 models: random forest, k-nearest neighbor, decision tree, gradient boosting, and the fifth one is RNN model using Keras. Okay, RNN is nothing but a recurrent neural network for natural language interface using a TensorFlow and Keras. The model architecture consisting of LSTM layer with the 64 inputs, followed by a flattened layer and 2 dense layers with 128 units and 3 units for softmax activation corresponding to the 3 classes: entailment, neutral, and contradiction, respectively. The training is conducted for the 5 FOs with a batch size of 64, and the model's performance is tracked using accuracy as evaluation metrics. So all we have is a code here with related to RNN model using Keras. So we are importing the TensorFlow, and we are importing the TensorFlow from Keras, and importing the Keras as well, and sklearn pre-processing, and importing the label encoder from it is importing from matplotlib pyplot as PLT, and in this step we are converting the labels to numerical values, and we are converting the sparse matrix to dense tensor here. And this code says that reshape the data for RNN. This one represents the recurrent neural network RNN model. So this code represents the training with the history to capture the accuracy and loss during training. In this, we are plotting the training and accuracy and loss. In this step, we are plotting the training accuracy, all you have, and the training loss. This is all about the training loss, and finally we are showing it in the graph. So all you have is here the model sequential layer, output shape, and the parameter. So LSTM flatten. So you have got some values over here, and all you have got is total params is, it says like this value, and the trainable params is this one, and non-trainable params is 0, unfortunately. So as you can see, the training and validation accuracy, the graph, it shows this one, and the training and validation loss, the graph is on the right side. So the architecture of RNN designed for a neural network, neutral natural language interference. The model compromises as LSTM layer with 64 units, followed by a flattened layer and 2 dense layer with 128 and 3 units respectively. The LSTM layer is responsible for capturing sequential dependencies, contribute sequentiality to the model's parameter count. The training process is carried out for 5 epochs with a batch size of 64. The training and validation accuracy and loss curves indicate a learning process with accuracy starting at around 33% and improving to approximately 65% on the training set. However, the validation accuracy shows signs of overfitting, decreasing from 33% to 29%, suggesting the model might benefit from the further tuning or regularization techniques to enhance generalization on unseen data. The total number of parameters is around 1.3 million, and the summary provides the detailed breakdown of the layer-wise architecture and parameters. The plotted training and validation accuracy losses the curves provide a visual representation of the model's learning dynamic over the 5 training epochs. In the first subplot, the training accuracy steadily increases from around 33.5% to approximately 65%, indicating the model is learning to better predict the logical relationships in the training data. However, the validation accuracy starts at a similar level, around 33%, but shows signs of stagnation and a slight decline over subsequent echoes, suggesting a potential overfitting issue. The second subplot displays the corresponding training and validation loss curves. The training loss consistently decreases from approximately 1.1 to 0.77, reflecting the model's improvement in maximizing the loss function. Conversely, the validation loss shows an upward trend surpassing the training loss, reinforcing the concern of overfitting. These visualizations underscore the trade-off between training accuracy and generalization to unseen data, indicating that further optimization and regularization techniques may be beneficial to enhance the model's overall performance on the natural language inference task. The dimensions and feature selections, PCA. The code uses a PCA for the dimension reduction. PCA is a technique that transforms the original features into the new set of linearly uncorrelated features called principal components. The PCA class from scikit-learn is utilized with n_components equals to 150 to reduce the dimensionality to 100 components. This helps in addressing the cause of dimensionality, reduces computational complexity, and can potentially improve model generalization. So this is all about the PCA. So we have the following code, the fit and transform, fit_transform. So we are displaying the value of PCA. As you can see, we have got the array list of PCA, and in this one, like hyperparameter tuning, the random forest, the hyperparameter tuning, which is crucial for optimizing the performance of machine learning models. Grid search is employed to explore different combinations of hyperparameters for a random forest classification. The specialized hyperparameters include the number of estimators. Okay, so on the minimum samples required to split an internal node. So the class from scikit-learn is utilized for the purpose. So this is the following code for the hyperparameter tuning. We have exported all the necessary libraries. We have imported all the necessary libraries here in this one. And in this step, the hyperparameter tuning, there is nothing but a random forest. So yeah, this is a grid search and extracting the results in this step. We are extracting the hyperparameter for the plotting here, and we are plotting the figure finally, and using some loops to show the exact extract scores for specific param values. So all here is we are plotting all the details for the graph. So this is a grid search result for the random forest hyperparameters. So the grid search for the random forest hyperparameters are visualized in the plot where each line corresponds to a specific value of n estimators. The maximum path or the minimum sample split The x-axis represents the indication of hyperparameter combination ranging from 0 to 5. For n estimators, the plot displays 3 lines corresponding to the values of 50, 100, and 200. Similarly, max depth is represented by lines for none, 10, and 20, while the minimum underscore samples underscore split has lines for 2, 5, and 10. The y-axis denotes the mean cross-validated accuracy, providing insights into the performance of each hyperparameter configuration. The visual representation allows for a quick assessment of how changes in this hyperparameter influence model accuracy, aiding in the identification of optimal settings for the random forest model in the context of natural language inference. Coming to the another one, the model for random forest model evaluation. Following the hyperparameter tuning, the code evaluates the performance of random forest model with the best hyperparameters on the validation set. The best model is obtained from the grid search, and the predictions are made on the validation data. Accuracy and a classification report, including precision recall and F1 score, are computed to access the model's effectiveness. So this is a model evaluation, and you have got all the details for the random forest model evaluation. The accuracy you can see here 0.398923, and the classification report says precision, recall, F1 score, and support. So all we have is precision, recall, F1 score of 0, 1, 2 labels. Okay, you have got the different values for each of them. And coming to the accuracy, as you have got like micro average and weighted average. You have got the different values for both of them. And the accuracy you have got only for F1 score 0.40 and support 2424. So the evaluation of random forest model on the natural inference. So this is all talks about the above one. And coming, this comprehensive process ensures that the machine learning model is fine-tuned for optimal performance, making it well suited for the final project's requirement. Okay, so here we are importing the Seaborn as a SSN. Okay, and this is a confusion matrix. For this one, we have used the following code, and we are showing it here with the PLT and dot title. So as you have got all the details of the confusion matrix, the confusion matrix for the random forest in the model context of natural language inference reveals how well the data model performed in predicting the logical relationship between the premises and hypothesis across the three classes, that is entailment, neutral, and contradiction. Each row in the matrix represents the true classes, while each column represents all the predicted classes in the diagonal, and the number indicates the instances where the true classes matches the predicted classes. For example, in the class 0, the model correctly predicted 663 instances, while in the class 1 neutral and the class 2 contradiction, the correct predictions were 268 and 505 respectively. Off diagonal element indicates misclassification, providing insights into areas where the model may struggle. Overall, the confusion matrix aids in understanding the distribution of prediction and misprediction across the different classes, contributing to a comprehensive assessment of the model's performance. Finally, the conclusion. In summary, tackling the natural NLI, natural language inference challenge with a multilingual context has proven to intricate and demanding. The thorough investigation encompassed the development and assessment of diverse machine learning models, encompassing traditional classifiers such as random forest and a neural network architecture like LSTM. Despite hyperparameter optimization, the random forest model achieved an accuracy of approximately 39.9 on the test set, encountering notable difficulties in accurately predicting instances within the neutral classes as envisaged As evidenced by the classification report and confusion matrix analysis, the exploration extended to incorporating a neural networks model, especially the LSTM architecture, though its performance did not surpass that of the random forest model. The training and validation plots for the LSTM model revealed convergence challenges, suggesting potential advantages for further refinement, including hyperparameter tuning and exploration of a alternative neural network architecture. In conclusion, addressing the complexity of NLI in a multilingual settings requires ongoing refinement and experimentation. Future efforts should delve into the advanced neural network architecture, fine-tuning hyperparameters, and conducting a more extensive analysis of linguistic pattern to enhance more model performance. This comprehensive exploration not only sheds light on the intricacies of multilingual NLI, but also lays the groundwork for the continued advancement in tackling these challenges, natural language processing problem. So this is all about our project. Final project is about, and we have taken the dataset from this link. This one is a contradictory, my dear Watson, detecting contradiction and entailment in multilingual text using TPUs. This is all about our Kaggle data competition dataset. And we have performed 5 machine learning models, as you can see here, as discussed. So let me just show you once again what are all the random forest, k-nearest neighbor, decision tree, gradient boosting, and the final one, RNN model using Keras. Okay, so this is all about our final machine learning project. Thank you. We have we have already made a PPT and also made a Word document, also a PDF for the references. We will be uploading our PPT, which I have been explained here so far. The same thing is the same content is present in this PPT. Also, you can see the Word file and a PDF file, and I have attached everything. And when you go here in this one, you have to run the code. So this is all about our assignment. Thank you.
Thank you.
Thank you.
Someone can stop the video. I'm not able to stop it.
I am going to stop that. Stop recording. Stop.